this case, solve for y, but I would first simplify and say y squared, x squared, y to the fourth equals 4. And if I do solve for y, I will have 4 over x squared, and I will have to take the apply the fourth root to both sides. I don't want to do that. I could. Instead, I will differentiate both sides, keeping in mind that y is a function of x. How do I know? Because I'm asked to find dy over dx. Because I'm asked to find dy over dx, in the question, it's very clear that y is a function of x. So this is a product of two functions, function 1 and function 2. I have to use the product rule. I differentiate the first function, I get 2x multiplied by the second function, plus the first function multiplied by the second function prime. But this is this formula, which is 4f to the third times f prime. So 4 y to the third power times dy over dx equals 0. When I differentiate 4, I get 0. Okay, what am I solving for? This is what I'm solving for, which means I have to take this part to the other side and divide by this. So I'm going to clean it up first. I'm going to write 4 x squared y to the third times dy over dx, and I get negative 2x y to the fourth, and now I will divide by this, both sides. So dy over dx equals negative 2xy to the fourth over 4x squared y to the third. Yes, I will simplify right now. What can I simplify by? I'll simplify by 1x. I'll simplify by 3y's. And I'll simplify by 2. So then dy over dx becomes negative 1/2 y over x. At this point, I go back and I say, okay, it really tells me to plug in when x is 2 and y is negative 1. Fine. Negative 1/2, x is 2, y is negative 1. The answer, 1/4. This is what we call implicit differentiation. We are not differentiating directly, we are differentiating implicitly. This was an example in which I was able to solve for y. But here's an example in which I'm not able to solve for y, no matter what I do. So let's look at 22. Same page, 279. So we have x cubed, y squared, plus x to the fifth, y to the third, equals negative 19. I don't want you to draw the conclusion that the right-hand side will always be a number. No, that's not the case. It just seems like most of the examples or problems here do, but no, it doesn't have to be. No one can solve this for x cubed, for y. The question is the same. We want to find dy over dx, and this is our only choice here. Differentiate the left-hand side, differentiate the right-hand side, and I have to consider a product and another product. So 3 x squared y squared plus x cubed times 2 times y times dy over dx plus, so this is only this differentiated. Now I'm here. 5x to the fourth y to the third plus x to the fifth times 3 times y squared times dy over dx. I ran out of room, of course. It's not unusual. Equals 0. Don't forget to write equals 0, otherwise you will not be able to solve for anything. So at this point, I'm solving for this. These two terms have to go to the other side, and I will factor out dy over dx. 2x cubed y plus 3x to the fifth y squared, and I pulled out dy over dx. On the other side, negative 3x squared y squared, because they're both negative, I'm going to put them in parentheses. Of course, I'll divide both sides by what multiplies this. So dy over dx is negative in front. Let's see what we can pull out. I can pull out an x squared, and I can pull out a y squared. So it's x squared y squared. So it's 5 x squared y plus 3. Let's see what we can pull out from here. An x cubed and a y. So x cubed and y, I have 3x squared y and x cubed y plus 2. I can simplify a y with a y from the top, 2 x's with 2 x's from the top and bottom, negative. There is a y in front, and 5x squared y plus 3, and the denominator x, 3x squared y plus 2. So even if we don't know how the function looks like, we can determine an expression of its derivative. So we can determine the rate of change of that function that we don't even have, and we don't even know how it looks like. You could say, yeah, but you still depend, this expression still depends on y. I have to agree, it does. But although I don't have y, I can still have an expression for dy over dx. So this is implicit differentiation. We can still determine an expression for the derivative and also determine its rate of change. Okay, let's look at another application with related rates this time, but maybe we should look at another example. Yes, let's look at one more. Let's say 30 on page 279. So 1,000 minus 300p plus 25p squared equals x. And the question is asking us to find dp over dx. That clearly states that p is a function of x, and I will not attempt to solve for x, for p. Absolutely not. Don't even try. So we'll differentiate implicitly. This is 0. So this will be negative 300 p prime, but it's dp over dx. I do not recommend using p prime because you may be lost in translation, as we say, and you may drop it or you may make a mistake. So this is the correct notation for implicit differentiation. Plus 50p times dp over dx equals x prime. That is a variable, which is 1. I will factor out dp over dt, dx, oh, sorry, thinking of related rates already. So this is 50p minus 300 equals 1. So then dp over dx is 1 over 50p minus 300. Yeah, you can factor out 50 in the denominator if you want to, so it's p minus 6. So dp over dx looks like this. I want to have these on the same line, sorry. all the fraction lines and the equal symbol should be lined up. Okay. So now let's see how we apply implicit differentiation in different word problems. Let's see what we have on page 280. Let's start with problem 40. Before I forget, because I always forget, chapter 2 homework should be done as soon as possible between now and Tuesday, please, not to forget and not to fall behind. And a few quizzes will come up, quiz for Tuesday and quiz for Thursday. I will post them as soon as possible. Okay, so it says the rate of change of a healing wound, 40 on 280, is given by the following relationship. The radius is decreasing at a rate of 1 millimeter per day. Maybe I should just erase that and write it again. So it's 1 millimeter per day. And it's decreasing. So when we talk about a rate that is decreasing, what is the sign? And we know that from graphing as well. When we talk about decreasing, what is the sign of the derivative? Decreasing, 1 millimeter per day. What is the sign when a function is decreasing? What is the sign of the derivative when the function is decreasing? So it's -1 millimeter per day. And this is dr over dt, the rate of change of radius with respect to time. How do I know it's dt? Because of this. The days, time, minutes, hours refer to rate of change of radius with respect to time. Radius in millimeters, days, time in days in this case. At the moment when r is 25 millimeters, how fast is the area decreasing at that moment? So basically, we are dealing here with two functions. Both of them are functions of time. Area is a function of time. R is also a function of time. They are both decreasing. So I expect that dA over dt, this is what we're asked to find when the radius is 25 millimeters and when dr over dt equals -1 millimeter per day. So this is the question. Well, I have to find dA over dt first before I plug in all these numbers. Going back to the equation that was given to us and differentiating it implicitly, or simply differentiating it in this case because I have the equation, I get dA over dt, because it's a function of time, equals pi times 2 times r times dr over dt. At this point, all I have to do is just plug in the numbers, the given numbers. So when r equals 25 and dr over dt equals -1. Okay, so 2 pi, r is 25, and dr over dt is -1. So exact is -50 pi. Measurement unit is in millimeters squared per day. If you want to approximate, you can. It's 50 multiplied by 3.14, or you can use 50 multiplied by the exact or the best approximation I can come up with. And it's negative, of course. So negative 157.08 millimeters squared per day. Any questions? Let's look at body surface area. Any questions on this? So keep in mind that that's one of the results or conclusions from the graphing. Just remember, every time a function is decreasing, its rate of change is negative. And vice versa. Okay, so let's look at the body surface area. So 41 on page 280. Certain chemotherapy dosages depend on a patient's surface area. According to the model, S equals the square root of HW divided by 60. H is the patient's height in centimeters. W is the patient's weight in kilograms. Okay. And S is the approximation of the patient's surface area in square meters. Perfect. Assume that Kim's height is a constant, 165 centimeters. But she's losing weight. If she loses 2 kilograms per month, lost, right? How fast is her surface area? So this must be dW over dt, W in kilograms, time in months. How fast is her surface area decreasing at the instant she weighs 70 kilograms? Okay, so this is a constant, this is the only variable, and this is the second variable. So S and H are functions of time. So the S over dt equals, the height is the square root of H divided by 60. I'm not going to bother with that. That's a constant. So what I do have is W with the square root on it. And we know that this is 1 over 2, the square root of W times W prime, which is dW over dt. I'm going to erase that so it's not confusing if you decide to go back and look at the notes. I didn't want you to have anything there. So what I did was, I was told that the height is a constant, 60 is a constant, so I took that out in front. And now I'm only differentiating the square root of W, which is 1 over 2, the square root of W times W over dt. So the question is asking us to determine this. When the height is 165, and when W, we were told in the problem, when at the instant she weighs 70 kilograms. I have all the information I need, so I will continue. The square root of 165 divided by 60, multiplied by 1 over 2, the square root of 70, and multiply by negative 2, which will go away with this. So now what I'm going to do is, do I want to do that or that? Doesn't matter, really. So the square root of 165 and then divide by, please put the denominator in parentheses, 60, the square root of 70, and close the parenthesis, and I got negative 0.02558. I don't know, they didn't say how many decimal digits they want. But this is basically it's surface area, but it's ds over dt, so it's meters squared per month. So why is all this called related rates? Why is it called related rates? It's because, you see, there is an equation that relates the variables one to each other, and there is another equation that relates their rates of change. This is the equation. This is the equation that says that ds over dt equals blah, 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 dw over dt. So there's an equation that relates, that links together, if you want, the two rates of change. So that's why this whole concept is called related rates. So the variables are related, therefore, through an equation. Therefore, their rates of change are related as well.